Hello, welcome to another interesting topic. I always wondered how the spacecraft move in space, where there is nothing to push against. Welcome to the mysterious cosmos, where the rules of motion we're accustomed to on Earth seem to be written in a different language altogether. Today, we're diving into the fascinating world of space propulsion. In the vast expanse of space, a vacuum that's devoid of air or any medium to push off, it's intriguing to imagine how spacecraft can move, speed up, slow down, or change direction. It might seem counterintuitive, but the principles guiding this motion are rooted in the fundamental laws of physics we're all familiar with. Remember Newton's third law of motion? For every action, there is an equal and opposite reaction. This law forms the cornerstone of space propulsion. So, if space is a vacuum, how do spacecraft propel themselves? Let's uncover the mystery. To understand space travel, we first need to grasp the concept of propulsion. So what is propulsion? In simplest terms, it's the action of driving or pushing forward. It's what makes your bike move when you pedal, or your car go when you step on the gas. But let's dive a bit deeper. Propulsion is all about Newton's third law of motion. For every action, there's an equal and opposite reaction. Imagine you're on a skateboard. If you throw a basketball away from you, the force of that action propels you in the opposite direction. The basketball is the action, and you moving backwards is the reaction. In a more technical scenario, like a jet engine, air is sucked in, compressed, mixed with fuel, and ignited. The resulting hot gas is expelled out the back at high speed. This action of expelling gas backwards results in an equal force pushing the jet forwards. That's propulsion at work. But what about in space? It's a vacuum, right? So there's no air or ground to push off of. Well, that's where rockets come in. Rockets work on the same principle of action and reaction. The rocket's engine burns fuel to produce a high-speed stream of gases which are expelled out the back of the rocket. This action creates a reaction force that propels the rocket in the opposite direction. And what's really cool is that this works no matter where the rocket is, even in the vacuum of space. That's because the rocket isn't pushing against the air or the ground. It's pushing against its own expelled gases. This might seem counterintuitive, but remember, it's all about the action and the reaction. The rocket's action is to expel gases backwards, and its reaction is to move forwards. And this is the fundamental principle of propulsion that makes space travel possible. Now, keeping this concept in mind, let's see how it applies to space. In space, propulsion works a bit differently than it does on Earth. You might be wondering, in the vast, seemingly endless expanse of the cosmos, devoid of air or any solid material, how does a spacecraft move? Well, it all comes down to a little thing we call rocket science. Let's dive a bit deeper. The fundamental principle underlying space propulsion is Newton's third law of motion. For every action, there is an equal and opposite reaction. In simpler terms, if you throw something in one direction, you'll move in the opposite direction. This is the basic idea behind rocket engines. Rocket engines work by ejecting mass in the form of high-speed exhaust gases out of the back of the rocket. This ejection of mass creates a force known as thrust, which pushes the rocket in the opposite direction. The more mass you eject and the faster you eject it, the greater the thrust. This is why rocket engines burn fuel at such a high rate to generate the maximum amount of thrust. However, it's important to note that once a spacecraft is in space, it doesn't need to constantly fire its engines to keep moving. Thanks to the lack of friction in space, once a spacecraft is set in motion, it will continue to move at a constant speed and in a constant direction unless acted upon by another force. This is another fundamental principle of physics, known as Newton's first law of motion, or the law of inertia. But of course, space is not entirely empty. There are gravitational forces from nearby celestial bodies, such as planets, stars, and galaxies, which can affect a spacecraft's trajectory. So while the engines might be off, the spacecraft is still being influenced by these external forces. Now you might be thinking, okay, I get how a rocket moves forward, But how do spacecraft control their speed in the vast emptiness of space? Let's find out. Controlling speed in space is not as straightforward as it is on Earth. When we think about speed control in space, we must consider a key player: thrust. Thrust is the force that moves a spacecraft through space. It's produced by the engines of the spacecraft, pushing it forward. Imagine you're floating in space with your spaceship. If you want to speed up, you increase the amount of thrust. This pushes your spacecraft forward, increasing its speed. But what if you want to slow down? This is where things get a bit tricky. In space, there's no friction to naturally slow you down. If you stop thrusting, your spacecraft won't gradually come to a halt like a car does on the road. Instead, it will keep moving at the same speed forever, unless it's acted upon by another force. This is due to a property of space called inertia. So to slow down, you need to reduce your speed in a different way. This is where the concept of retro rockets comes into play. Retro rockets are small thrusters that produce a force in the opposite direction of the spacecraft's movement. By firing these retro rockets, you can effectively slow down your spaceship. But there's another way to brake in space, and that's by using atmospheric drag. This method is particularly useful when a spacecraft is re-entering the Earth's atmosphere. As the spacecraft encounters the dense layers of the atmosphere, it experiences a drag force that slows it down. This is the same principle that makes a parachute slow down a skydiver. However, both these methods require careful calculation and precise execution. Too much thrust could send your spacecraft off course, and too much drag could cause it to burn up in the atmosphere. So, as you can see, controlling speed in space is a delicate dance of forces, requiring a deep understanding of physics and precise control of the spacecraft's systems. Now that we've understood speed control, let's look at how spacecraft change their direction in space. Changing direction in space is a unique challenge due to the lack of friction and the laws of physics. In the vastness of space, traditional methods of steering just don't apply. So, how do spacecraft manage to change their direction? The answer lies in two key techniques: thrust vectoring and the use of gyroscopes. Let's talk about thrust vectoring first. As you may recall from our discussion about propulsion, thrust is the force that propels a spacecraft forward. Now imagine if we could manipulate the direction of that force. That's exactly what thrust vectoring is. By changing the direction of the exhaust gases, we can change the direction of the spacecraft. Think of it like an invisible hand, gently pushing the spacecraft to either side or up and down. This is one way spacecraft change their direction. The second technique is the use of gyroscopes. Now, a gyroscope is a spinning wheel or disc whose axle is free to take any orientation. This orientation does not change due to the law of conservation of angular momentum, which makes gyroscopes incredibly useful for maintaining or changing orientation in space. Spacecraft use gyroscopes to change direction without using any fuel. When a spacecraft wants to turn, it spins up a gyroscope in the opposite direction. The spacecraft then turns due to the conservation of angular momentum. But there's a catch. The spacecraft will keep spinning unless it stops the gyroscope or spins up another one in the opposite direction. This is why spacecraft often have multiple gyroscopes to balance out the spinning and maintain control. Spacecraft changing direction isn't as simple as turning a steering wheel. It's a delicate dance of physics and engineering, a testament to human ingenuity. And it's all happening right above us, as satellites orbit and probes explore the far reaches of our solar system. So, even in the vacuum of space, movement is possible thanks to the laws of physics and innovative engineering. Spacecraft roaming the cosmos, changing direction and course, is a testament to our understanding of these laws and our ability to engineer solutions to complex problems. Space propulsion might seem complex, but it's based on fundamental principles of physics. Today, we've untangled these principles, shedding light on how spacecrafts navigate the seemingly empty expanse of space. First, we delved into the concept of propulsion, understanding that the conservation of momentum is key. A spacecraft propels itself by expelling part of its mass backward, which in turn pushes it forward. Next, we explored how speed is controlled in the vacuum of space, where there's no air resistance or friction. The spacecraft adjusts its speed by varying the rate at which it expels its propellant. We then discussed how brakes function in space, a concept that involves the spacecraft changing its velocity or direction rather than halting to a stop as on Earth. Lastly, we explained how direction changes are achieved using thrusters that fire in the opposite direction of the intended path. So, next time you watch a spacecraft launch or marvel at images from distant space probes, you'll know just a bit more about the incredible science and engineering that makes it all possible. Thanks for watching. Stay tuned for more interesting videos like this. Like, share, and don't forget to subscribe. Have a nice day.